All right. In this video, we're going to be looking at the chi-squared test, but with what is called the Yates continuity correction. So we're going to take a little situation. Medical researchers classified each of a group of men as high or low blood pressure, and then watched them for 5 years. Men with blood pressure of 140 millimeters or higher, or more were higher, and others were low. So here's the results of the study. And they looked at the death rate of these men and whether they survived. Did low or high blood pressure have anything to do with it? Now, I know this is, you can definitely tell that it doesn't look like it makes much of a difference. But I'm just using it for the data of it. That here's my observed table is coming straight from this. We have low blood pressure and high blood pressure, and how many died in those 5 years and how many survived. So I'm going to copy down that data. A lot of this is going to be the same as the other chi-squared test. First of all, the whole fact of we have to have an expected value table, and that the expected value table is actually found by, we need to have our row total times the column total divided by the total. And so this goes into the same thing. So I need my row totals and the other row total and the total. And I want to double check a few things. One of the things I tend to double check is I added these two up to find my total, but I also need to double check that the columns add up to be the same thing, and they do. So when I'm doing my expected values, I'll do this one a little bit bigger. Okay, so this is died, survived, low blood pressure and high blood pressure. Which just for 5 years, this doesn't really make a lot of sense. But that's okay. So for this section, we're going to look at that row and that column. So 2676 times the column total of 76 divided by my overall total of 6014. Gives me 33.8. Now I'm going to do the same thing for the next one. 2676 times 5938 divided by 6014. And this one's going to be row, column, total. And then 3338 times 5938 divided by 6014. So row total, column total, divided by your overall total. Whoa, I messed up somewhere. Now, if I were doing my IA, and I noticed that these were very, very similar. I'm realizing I probably should have gone one decimal place here. that 2655 is very close to 2642. So if I was doing my IA, I might spend some time talking about how close my observed values are to my expected values, even as I speak. So the next part is to apply the formula. Now, for Yates continuity, which you must use if you have a 2x2 table. This is new for this year in IB. The formula for Yates continuity. You still have your summation, and you're still ending by dividing by your expecteds, and you're still squaring, but we take the absolute value of the difference between my observed and expected, and then there's this adjustment, this Yates continuity correction, which is to subtract 0.5 from that difference. Don't ask me why. There's people that actually argue about Yates continuity, whether it's valid or not. My question is not to ask why, but to do or die, to just do the work. And that's what we're going to do. So we're going to take the low that died. We're going to take the high that died. And then we're going to take the low that survived. And then the low, the high that survived. In our first column, we're going to need the observed. So low that died, the observed table, that would be what comes from your surveys or what comes from your internet research or your experiments. This is your observed. Now we just calculated the expected table. And when you put it in a chart like this, it's also a good time to look at it and go, wow, they are kind of similar. Now, the next part of the formula says to take the difference, but to take the absolute value of the difference. So, all we have to do is subtract them, but subtract them in such a way that you will always have a positive. So 33.8 minus 21. So I subtracted them in a way that I was going to have a positive answer. The next thing I'm going to do is subtract 0.5. So I'm taking that observed minus expected, and I'm going to subtract 0.5. Getting a 12.3. The next step is to square it. So I'm going to take that observed minus the expected minus 0.5 and square it. So 12.3 squared, and I get 151.29. Now notice the last part of the formula is to divide by your expected. So the last column here, I'm going to take the observed minus expected minus 0.5 squared divided by the expected. In other words, I'm going to come back over here and divide that by 33.8. And I'm going to repeat that process. So the absolute value of the difference, I'm going to take the 55 minus 42.2. That way I know I have a positive number. I'm going to subtract 0.5. And then I'm going to square that. And then divide that by the expected. Continue. 2655 minus 2642.2 and get a 12.8. Wow, it ended up being a 12.8 as well. So that's going to mean this is a 12.3. That was unusual. 151.29 divided by 2642.2. Wow, this doesn't always happen, that they come out to be exactly the same. But notice what didn't come out the same. These values at the end came out very, very different. Now to find our calculated chi-squared value, chi-squared calculated, all we're going to do is add them all up. 4.48 plus 3.59 plus 0.057 plus 0.046. And I get 8.173. Now remember, we're going to compare that calculated value to a critical value. The critical value comes from a table. The critical value for this one, with degree of freedom of 1 and a 5% significance level, so degree of freedom of 1, which if you're using a 2 by 2, that's all you're going to have. And we always do the 5% significance level. So most of you who are watching this video are actually going to be using the same critical value. That critical value is 3.841. How did ours compare? It's actually much greater. So even though it looked like there really wasn't maybe something going on, because our calculated value is so much higher than the critical value, remember that's our cutoff point, I would actually say I reject the null hypothesis. High blood pressure and death rate are not blood pressure and death rate are not independent. And we actually were able to tell that from such a small chart. But that's the only difference in the chi-squared tests, is that for this one you have to add just one extra little column.